All right, so let's take a few minutes to talk about Lesson 4, Ordering Rational Numbers. So before starting this video, you should have took about 5 to 6 minutes to solve 4.1. So how do they compare? Use the symbols greater than, less than, or equal to compare each pair of numbers. Be prepared to explain your reasoning. So 12 to 19. Well, 12 is less than 19. Okay? 212 is greater than 190. 15 is greater than 1.5. 9.02 versus 9.2. So we have to look at the number in the tens place. And the number that's bigger in the tens place is going to be the bigger number since they are both a whole number of 9 at the beginning and then a decimal point after. So 0.02 is actually less than 0.2. So 9.02 is less than 9.2. All right, 6.050 versus 6.05. This is actually just the same number. We could even put a 0 here to make it the same. But if you drop the 0, they are still the same. So they are equal. Okay, 0.4 and 9 out of 40. So best practice for this, we're going to have to figure out, well, we need to change that 9 out of 40 to a fraction. Or not to a fraction, but we can either change that to a fraction, a decimal, or change this one to a fraction. So we know that 0.4, this actually might be easier to change this to a fraction. 0.4 is actually 4/10 because you write the fraction how you would say it. So 4/10, okay? So 4/10 compared to 9 out of 40. So if we were to make them the same denominator, this would be times 4 times 4. So this would actually equal 16 over 40. And we know that 16 over 40 is bigger than 9 over 40. Okay? So that makes 0.4 bigger than 9 out of 40. All right, 19 out of 24 versus 19 out of 21. So remember, as the denominator gets bigger, the parts get smaller, okay? So 19 out of 21 is actually going to be bigger than 19 out of 24 because remember, splitting something into 24 and taking 19 of them is going to be less than splitting something into 21 and taking 19 of those. Okay, and then this last one, so we've got 16 out of 17 versus 11 out of 12. So this one could be a little bit tough, so we might have to convert these to decimals. So if you have your calculator, you can just stick in your calculator 16 over 17, and you would get around 0.94, we'll round, and then 11 out of 12 is going to be around 0.92. So that makes 16 out of 17 bigger. All right, so for 4.2, ordering rational number cards. So what I'm going to do for this section is I'm going to flash some numbers up, and you are going to pause the video and order these numbers from least to greatest. Okay? So here are the numbers. You have 10 numbers. I need you to order them from least to greatest. So now would be the time to pause the video, order from least to greatest. All right, so now that you've had time to pause the video and order these from least to greatest, I always start with separating my numbers by the ones that I know that are positive and the ones that I know that are negative. Okay, so when looking at them, we've got a negative 11, a negative 4/3, a negative 2.5, a negative 6/7, and a negative 8.8. Okay, so we know all negatives are automatically going to be smaller than the positives. So we're going to start with ordering the negatives from least to greatest. Okay, so if I were to order these from least to greatest, I would start with the bigger number. So negative 11 is actually going to be the smallest that we have. Okay, then negative 8.8. Okay, if we were to figure out what this is, since the numerator is bigger than the denominator, this is actually -1 1/3, okay? So the next smallest number is going to be the -2.5, okay? Then the -4/3, and then the -6/7. Okay? So now looking at our positive numbers. So we've already organized our negatives. So let's see what positive numbers we have. So I see that we've got a 9, a 0.5, an 11/2, a 4, and a 5/2. Okay? So looking at those, we need to figure out which is the next smallest number. So which positive number is the smallest? So 5/2 is going to be the same as 2.5, positive 2.5. 11/2, so we know 2 can go into 11 5 times with 1/2 left over. All right, so let's go ahead and organize these. So if we're looking at them, we know that 0.5 is going to come after 6/7. All right, then we have the 5/2, then the +4, then the 11/2 because that stands for 5.5, and then the 9. Okay, so here is our complete order of the numbers you were given from least to greatest. So we've got a -11 was the smallest number, and the largest number was a 9. All right, so let's move on to 4.3. So for 4.3, use each of the following terms at least once to describe or compare the values of points M, N, P, and R. Okay, so yours might look a little bit different than mine, okay? So I'm going to start out with M, and I'm going to say that we know M is less than N, okay? We know P is greater than N. Okay, let's see if we can find one that is opposite. Let's see. So M and P are opposites because they are both 5 spaces from 0. Okay. N and M are negative because they are less than 0. So we also need to say something about R. So R is actually greater than all of them. So we could really say R is greater than P, R is greater than N, R is greater than M. Okay? All right, and you might have had some more if you can think of. We can discuss those out loud. All right, for part 2, tell what the value of each point would be if, okay, so again, we're using that same number line, okay, so P, we're saying that P is at positive 2.5. So that means that each of the ticks would count as 0.5. So if P is at 0.5, then R is going to be at, if we go up, if we look at the graph again, we're saying that P is 2.5. So that means that this would be half, 1, 1/2, 2, 2.5, 3, 3.5, 4. So R would have to be 4. Okay, M and N. So then that means that N is going to be -0.5, -1 would be N, and then -1.5, -2, so then -2.5 would be M, -2.5, then we said this would be -1. And this is true because remember when we talked earlier comparing, we knew that P and M were opposites. So that means no matter what P and M are, then they're going to have to be opposites each other. So if this one's a positive 2.5, this one has to be a -2.5. if m was set up as a -5, p would have to be a +5. All right, so n is -0.4, okay? So it looks like then we would have to, so thinking about it, if n is -0.4 and there's one tick between, half of -0.4 is going to be -0.2, okay? So that means we're counting by 0.2. So that means that p is going to be 0.2, 0.4, 0.6, 0.8, 1. So p would be +1. Okay, then that means r and m. So if we know that p is +1 and p and m are opposites, m has to be -1. And then r is 3 spaces from p. So if we're going by 0.2s, r would be 1.6. All right, this time r is 200, so we need to find p, m, and n. Okay, so we go back to our graph. Okay, it says that r is going to represent 200. So I'm just going to draw that this time. So let's see how many spaces between. So we've got 1, 2, 3, 4, 5, 6, 7. Or 8. We've got 8 spaces. So if we divide 200 by 8, that means we're counting by 25s. So 25, 50, 100. Oh, I skipped to 75. So this is 75. This will be 100. This will be 125, 150, 175. So that means P would have to be 125. Negatives counting by 25s. We've got -25, -50, -75, -100, -125. So M would be -125. P would be +125. And N is -50. All right, last one. So if M is -15, remember P and M are opposites, so P has to be +15. R and N we have to find. So if we're saying that P is at 15, there are 5 spaces between P and 0. So if we divide 5 by P, we get that the tick marks are counting by 3s. So N is going to be -6, okay? And R, if we go up 3 spaces from P by 3s, so we would have 27. All right, and if this confused you just a little bit, just make sure that you ask questions, okay? So remember, the big thing is when you have a number line and they tell you that a specific point is something and you're counting, you've got to figure out what we need to count by. So an example, you know, if we said that J was equal to 90, that means that there are 3 spaces from 0. 90 divided by 3, each space had to count by 30s. Okay? All right, so go ahead and start your homework for lesson 4.